so what we're going to look at now are matrices. This topic, some people do this in high school, some people don't, so I'm sure this will be new for some people. Okay. Okay. Something's not right here. Pencil. That's better. Okay, so matrix. Can you still see that? Yeah, that's okay. I know it's a bit dark, isn't it? That's better. Okay. Right, so what's a matrix? A matrix is a grid of numbers that obey certain rules of algebra. So that's kind of the simple definition. What I mean by a grid, that's a grid. There's other words for it as well. Array, block. But by grid, I mean like this kind of square shape of numbers. And matrices have their own rules of algebra. So here's some examples anyways of what they look like. So you could have one like this, maybe one like this, one like this. They're all blocks of number. This one here has 2 rows and two columns. This one here has 2 rows and 1 column, and then this one here has 1 row and then 2 columns. So we say that this one is a 2 by 2 matrix, this is a 2 by 1, and this is a 1 by 2. So that's some vocabulary for you. And another piece of vocabulary. This one here is called, sometimes people just call this a square matrix because of its shape. No, sadly not, doesn't work like that. If you were going to give them a name, this one here be called a column matrix, and this one be called a row matrix. Okay, so I said there's certain rules here. So what are those rules? Can I scroll down? Yeah. Okay, so the rules are the easy ones first. So if you want to add, like for example, this matrix, A, B, C, D, plus, let's say this one, E, F, G, H. Now I said this is an easy one because the rule is what you might guess the rule to be. You add each part, so A plus B, sorry, not A plus B, sorry, A plus E, B plus F, C plus G, D plus H. So that's the first number, A plus E. Then the second number, B plus F. That's that one and that one. Then the next one, C plus G. That goes there. And then the last one, D plus H. That goes there. So for example, 1, 2, 4, 0 plus 1, 2, 2, 3. That would be 2, 4, 6, 3, like that. Okay, do you have that taken down? Yeah. And I won't even bother to write it out again, but if you wanted the rule with minus, it's exactly the same, except they all get minus. So I'm not even going to bother to write that out. Okay. Can you always add two matrices? No, you can't. They need to be the same size. So that's important. So if I call this one A and this one B, and I want to add them together, A and B must be the same size. So if A is 2 by 2, then B must be 2 by 2. Otherwise, you can't add them. So, for example, no answer here. Same shape. Yeah. So if you look here,
like even and odd numbers, but do they, like if I want to add 4 plus 2 because they are even? That's what you say.
Oh no, they have to be the same shape. So if you see here, this one has 1, 2, 3, 4 numbers. Yeah. This one here only has 2. You can't add them together. Yeah. Okay. Now. That's adding and subtracting, really. What about multiplying? Well, there's two types of multiplication. So first one, multiply. So I'll just write multiply 1. I'll do the easy one first. So this is when you have a number and you want to multiply it by a matrix. Again, it's easy because it's what you expect. You multiply each part of the matrix by the number on the outside. So this is a bit like when you expand. Remember this verb?
Yeah.
It's a bit like that. And what's nice about this is that you really can always do it. So an example might be 3 multiply 1, 2, 3, 0. That would be 3, 6, 9, 0. Yeah. Well, that's what we're going to do next. Yeah. So this one, in this example, it's just one number and one matrix. So this one here would be a number and a matrix. Or as the physics students might know, vocabulary-wise, I could say a scalar and a matrix. So a single number and a matrix. Okay. So now the next one. Can I scroll down? Yeah. Yes? Yeah. Now the next one is the most difficult one. Okay? So this one is a matrix multiplying a matrix. So for example, A, B, C, D multiplied by E, F, G, H. Now let me tell you what it's not first. Not this. It would be great if it was this, but it's not. Okay. No. Okay, so it's not this. It's more complicated than that, unfortunately. So what is it then? Okay.
Isn't there all other columns?
Rows and columns, yeah. I'll try and do different colors here. Okay, so this is how you multiply two matrices. You do it by rows and columns. So what I mean by that,
If you put C, D, and G, I get it.
yeah, sorry, it's wrong and it's wrong as well. C, well, I mean, it's still wrong, but my point is lost a little bit. C, G,
D, H.
yeah, but I feel so bad about correcting something that's supposed to be wrong anyways. DH. Okay, so how do we multiply? So what we do is we take the first row and we multiply it by the first column. So I'll put that in grey. So that would be AE plus BG. So we go AE plus BG. And that's just the first number. Yeah, it's okay. Now the next one, do it in red. First row and second column. So that would be AF plus BH. That's the next one. Yep. Question is forming, spinning.
Confused.
Okay. Is there a question or you're just thinking?
No, I just looked up and there's like a lot of lines and colors.
Yeah, you see, your mistake was you took your eyes off the board. You never do that in maths class. Can I go on to the next part? You could probably figure out the way this is going. So the next one here will be the second row. Yeah. And the first column. So that would be CE plus DG. And finally, I'll do it in white here, the second row and the second column. So that's CF, I'll write it in black as well. CF plus DH. Let me add that in black. CF DH. Now I'll do some examples.
Will you show us example by the different matrices?
Yep, yeah. You mean like different sizes, or yeah? Because that's when it gets complicated. Okay, can I do an example? Some examples of this one. So, oops. For example, let's do an easy one first. So what's nice about this example is there's only one row and there's only one column, so there's only one multiplication. So the answer would be 1 times 3, which is 3, 2 times 4, which is 8, add them together, and it's 11.
Can you do it like in the
Oh yeah, we'll do all possible combinations. Yeah, we'll see what happens. So this is the kind of easiest one to do first. It's just one row, one column. Now, more normal would be something like this. Let's say these four, or this one. I haven't put a minus in yet. We'll do that some other time. Right. So this row multiply this column. So that'd be 1 plus 4. So that's 5 there. Now, this row, first row, second column. What would that one be? 5 also. Second row, first column, it'd be 3. And then finally, second row, second column, what's that one? 9. Now, I'll give you one to try. Okay. We'll do some more examples. The 9 here, the same. The 9 is this one and this one. So you do 3 by 3, which is 9, plus 0 by 1, which is 0. Okay, I'd like everybody to try this one for me. Make sure you got it. So when you practice a few of these, you can do them quickly. Okay, so this one here, let's see, it would be 3 plus 2. So did you get 5 here?
Yeah.
Yep. And then 4 plus 2, 6. 6 plus 1, 7. 8 plus 1, 9. Okay. Now let's do this one. So we'll do this one together. 3 plus 8, isn't it? Yeah? 11. And then 6 plus 4, 10. 1 plus 2, 3. 2 plus 1, 3. Now, what's the point I'm making with this example? No?
What?
No point?
The last one?
Yeah.
Is it something about the
No. Very good. If I call this A and this B, you can see that this one's B and this one's A. But look, you get different answers. Okay? So in fact, this is one example of how matrices are different to normal multiplying. If you multiply matrix A with matrix B, that's not the same answer as B multiply A. So they're actually different. And here's the example to show you that they're different. You don't get the same answer. So, in other words, you have to be careful about the order. It's important. Okay, now let's look at some more examples of multiplying. So you said, Tal, you want to see like the first one, but if they were swapped.
Yeah.
Yep. So let's take the first one again, but this time I swapped them. 1, 2. Okay. Did I swap them?
No.
I kept them the same.
No, you didn't.
I swapped the numbers, but not the shape. I want the column first. Okay. So 3, 4 multiply 1, 2 equals. Okay, so we do row by column. So what would that be? 3. Row by column, 6. Row by column, 4. And then row by column 8. Can you always multiply? Not always. Let me show you one case where it doesn't work. So if you look here, row, column. Now what's the problem here? The problem is you have 1 in the row here, but 2 in the column, which means there's no answer, because what do you do with the 4? 3 by 3, and then there's nothing left to go with the 4. So you can't do it here. It's not allowed. Well, you can't, because there's no number to match it up with. It's similar problem to up here earlier. Where's it gone? Here. The reason you can't add these together is because you can do 1 and 1, that's fine. 2 and there's no number here. So you can't, because the number's missing. Missing number problem. If anyone plays Pokemon, you'll get my reference.
Is it
Yes?
like
Some people got it?
Yeah.
Oh, good. Yes?
the row of the first one was equal to the column of the next?
Yeah, that the number, how many numbers you have in the first row must equal how many numbers you have. Oh, you want to how many rows and how many columns? Yeah. So if you look here,
The first one is
yeah, how many rows are in this one? 2. And how many columns? 1. And then here, how many rows? 1. And how many columns? 2. And this one's good, isn't it?
the 2 in the middle.
The middle are the same. Yeah. How many rows here? 2. And 1 column. And here, how many rows? It's 2 rows and 1 column. Basically, the problem comes down to these numbers not matching. Yeah, as you said here, they match. And of course, in the last example, this is 2 by 2, and then this one here is 2 by 2. So, because those numbers match, it means you can multiply. Let's have a look at another example. 1, 2, 3, 0, 1, 1. Okay, how many rows and columns here? What is it? It's 2 by 2, and this one here? 2 by 1. So I should be able to multiply them because these numbers match.
And the answer would be 2 by 1. Is that correct?
Yes, it would be, yeah.
But
2
if
rows,
you
1 column,
but
yeah.
if you
Yeah,
try
okay.
to multiply it like vice versa, then
I think there's a problem then the other way, isn't there? Yeah,
Yeah.
it doesn't work then the other way. So here we have row by column, so that's 3. Row by column, oh, so that's 3 in that example. But as you pointed out, I can't do this one because there's 1 here, but there's 2 here. So, no good. And again, you can see it because this one here is 2 rows by 1 column, and this is 2 rows by 2 columns. And because these numbers don't match, again, same reason, they can't multiply. Okay, next rule, what do you do if you have a power? So let's say 1, 2, 3, 4 squared as an example. Huh?
It's the same as multiplying.
Very good, yeah, it's the same as multiplying. All you do when you have a power is just write this out.
Yeah.
And that's it. So, you get row by column, what's that now? 7. Row by column 9, is that right? 2, 8, yeah, okay. Row by column 12 and 3, 15, yes. And then row by column 6 and 16, 22. And of course, it goes without saying, but notice that this is not 1, 4, 9, 16. Okay, see? It's not that.
what about division?
Hmm?
What about
Division gets its own lesson, because division is something more complicated again.
Are we going to
Unit matrices.
Like 1, 0.
Yeah, identity matrix, yeah.
Oh, identity.
Yes, yeah. But although unit matrix is something, it just means something different. Okay. Let's see. No, I think that covers all the rules. Oh no, sorry, there's one thing left to show you. Transpose. H.
What is transpose?
That's what you're going to see now. If I put a little t up the top of the matrix, like here, that's not a power, yep. It's part of finding the inverse, but we won't see it today, but it's one step in it, yeah. When you have a little t up the top here, it's not a power, it means transpose. And what that means is you swap the rows with the columns. You do a swap. So for example, instead of 4, 1 here, it's 4, 1 down. And instead of 2, 3 across, it's 2, 3 down. That's all. So here's another example.
Didn't some of them change their signs?
No, that's with inverse. That's something separate, yeah. Transpose is just a swap. This will be 1, 2, 3, 4 like that. 5, 6 transpose, that would be 5, 6 across. 1, 2 transpose, that would be 1, 2 down.
So change the count to.
Yep, that's all. That's the only change. So we have plus, minus, multiply by a number, multiply by a matrix, power, and transpose. Yep, that looks like it covers them all. Okay. Right. Got bad news for you. Bad news. I want all of these done.
Well,
Yeah.
seriously.
Now the reason I want all of these done is because I want this to become instant in the exam.
Can we do the shortcuts close to the?
I'm sorry, I must have stopped speaking English. I want all of these done.
No, I mean,
No shortcuts.
No, I mean not all of the steps to be written or anything.
If you can get to the answer without any work-ins, that's actually good, because that's what I want you to be like in the exam. I want to see matrix, answer, or matrix plus a matrix answer. I want you to be able to do this as if it was normal algebra. Do you understand? So there is a lot to do, but you have lots of time to do it. Now, I mean, I know it looks like a lot, but if you think about it, each question only takes maybe 10 to 20 seconds. So like the first one here, you could probably get that done in maybe 3 minutes. So it's not as bad as it looks. Of course I'm saying that, I'm not doing it. Yeah, page 14. So you can start it now. I'll take the attendance as well.